For more information, please visit SGMAK Associates website.
Hypothesis. We can establish under restricted assumption. It can be shown that a hypothesis can be tested using a confidence interval. So there's a connection between the two. In a confidence interval, we are setting an interval about a parameter and attaching a level of confidence to that interval. So as you attach more and more confidence, the interval becomes larger, and that happens, your estimation error also goes up. So you want to control the error of estimation, and later on we'll discuss that you can do that by just collecting more data, typically. The major takeaway is that both confidence interval and hypothesis testing relate to the parameters of a distribution. They both relate to the parameters of a distribution. Parameters of a distribution, common examples are mean and standard deviation. Depending on what distribution you're dealing with, they may have more than 2 parameters. For example, a triangular distribution has 3 parameters: the minimum value, the most likely value, and the maximum value. Normal distribution has 2 parameters, mean and standard deviation. A binomial distribution has 2 parameters, number of trials and probability of success in each trial. So parameters define a distribution uniquely. Depends on the type of distribution. Once you define the parameters, then you are able to estimate the probability attached with the random variable that you are studying. So remember that confidence interval and hypothesis testing both relate to the parameter. In statistical reasoning, most of the decisions are couched as a hypothesis testing. You observe, and then you set up your hypothesis based on your expectation. There is some theoretical basis behind that, but you don't know for sure. That's why you want to testing it. Collect data, perform the experiment, collect data, and then test the hypothesis. And take a decision based on that. Rejecting the null is one type of decision. Failing to reject the null is another decision. And we'll talk about it later on. Okay, bye now. Hi, here is a short audio file explaining what's the difference between setting up a confidence interval and testing a hypothesis. Both are important concepts in basic statistics or statistical analysis of data. So we set up confidence interval for a parameter such as mean, standard deviation. So you set them up for parameters only. The interval estimation consists of 2 parts. There we first get a point estimate, then we estimate the measurement error, or called the half width. Most often we do a 2-sided interval. Now examples of point estimates are sample average, sample standard deviation. The estimation error is also known as the half width for a 2-sided confidence interval. So interval estimate boils down to getting the point estimate and then adding and subtracting the half width to form an interval. The estimation error depends on the level of confidence, sample size, and the standard deviation. A confidence interval is estimated as I said before, is a point estimate plus minus the half width. Half width is also known as error of estimation. Now we attach a level of confidence with the confidence interval. A 95% confidence interval for mean implies that we are 95% confident that the true mean lies within the interval. A hypothesis is always tested on a parameter. So there's similarity. Confidence interval is set up for a parameter. Hypothesis is always tested on a parameter. We test a hypothesis for a specific value of the parameter. We hypothesize a specific value, collect data, and analyze it to check if the data supports the hypothesis. We set up, there are two parts when you set up a hypothesis. We set up a null hypothesis and an alternate hypothesis. And we test the data with respect to the null hypothesis only. Alternate hypothesis sits there as a default decision, not default decision, as a decision if we reject the null hypothesis, then that's the decision. We reject the null hypothesis if the level of support from the data represented by the p-value is less equal the level of significance of the test. P-value is a very important concept, and anytime you test hypothesis using a software, you get a p-value, and decision rule is always the same. You ahead of time you select a level of significance for the test, and if p-value happens to be less or equal to the level of significance of the test, then you reject the null hypothesis. You say you don't have enough support from the data for the null hypothesis, so reject it and accept the. Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.